crap cores or something.
Yeah, but that's not fair. Intel's own data suggests a single E-core can actually beat an older Skylake core at the same power level.
Or match its performance using way less power, like Skylake needed 2.5 times the power.
Something like that. And 4 E-cores could deliver significantly more throughput than 2 old Skylake cores with hyperthreading, using less power and fitting in roughly the same space as just one Skylake core. They're great for background stuff and scaling multi-threaded workloads.
Okay, so how does the system actually manage putting the right tasks on these different types of cores? That seems complicated.
It is, and that's where Intel Thread Director comes in. Your standard OS scheduler isn't really built for this kind of asymmetry.
So Thread Director is hardware inside the CPU.
Yep, it's a monitoring unit that watches the instruction mix, memory access, all sorts of things in real time for each thread.
And it tells the OS what to do.
It gives hints to the OS scheduler. It advises, basically, saying, hey, this thread looks like it needs performance, put it on a P-core, or this one's just background chatter, an E-core is fine.
Does it know about the hyperthreading on the P-cores?
It does. It understands the difference between a P-core's main thread and its secondary HT thread. So it helps the OS make smarter choices there too, aiming for the best performance and power use. Windows 11's scheduler is specifically designed to use these hints.
Right, better than Windows 10 for these chips. Okay, so let's get to the core question. What actually happens if you go into your BIOS and disable hyperthreading?
Well, the most obvious thing is you reduce your total thread count. On that i7-12800H, you'd go from 20 threads down to 14.6 from the P-cores plus 8 from the E-cores.
So heavy multi-threaded workloads, like video encoding or complex simulations, they'll likely take a performance hit.
Almost certainly, yeah. Single-threaded performance, probably not much change. Maybe tiny theoretical gains in some edge cases, but often negligible in practice.
What about gaming then? That's where a lot of the debate seems to be.
It's really nuanced. The argument for disabling HT in gaming is that you might get more consistent frame times, maybe better 1% lows, less micro stutter.
Why? Because the game threads aren't competing for resources on the same P-core.
Exactly. Less resource contention on that physical core. This might be more noticeable in older games or ones that aren't heavily threaded, and maybe less critical now you have E-cores to soak up background tasks.
But the argument against disabling it?
Well, in modern heavily threaded games, or if you've got a lot running in the background while gaming, HT can actually help. It gives the P-core more capacity to handle things simultaneously. Disabling it could even introduce stuttering or lower average FPS in those cases. Often, though, the difference is minimal either way.
And the E-cores play a role here too, right? Handling Discord, OBS, whatever else is running.
For sure. They reduce the need for P-core HT to juggle background stuff during gaming.
There have also been reports, particularly with the high-end 13th and 14th Gen i9's stability issues.
Yes, some users reporting improved stability, especially in certain Unreal Engine games, after disabling HT.
What's the theory there?
The thinking is that HT adds extra load, increases power consumption and heat. On CPUs already pushing high clocks and voltages, that extra stress might just tip them into instability. Disabling HT reduces that stress. It's kind of a workaround, maybe.
That connects to power and thermals directly.
Absolutely. Disabling HT consistently reduces power draw and heat output under heavy load. We're talking potentially significant drops, like 50 watts reported on an i9.
Wow. And lower temps mean more thermal headroom.
Which can translate to higher, more stable overclocks on the P-cores, maybe an extra couple hundred megahertz. And it's really important in thermally limited systems, like laptops.
Okay, one more big angle. Security.
Right. Because HT involves sharing core resources between threads, it inherently creates potential side channels.
How does that work?
Basically, one thread might be able to infer information about another thread running on the same physical core by observing timing variations or contention for shared resources like caches or execution ports. It often leverages speculative execution vulnerabilities.
We've heard people like L1TF, MDS, Port Smash, Spectre, Meltdown.
Yeah, some of those specifically exploit SMTHT to leak data. Data could come from caches, internal buffers, potentially sensitive stuff leaking between applications or even virtual machines.
So disabling HT is a valid security measure.
It's actually a very effective mitigation against the SMT-specific attack vectors, particularly for things like L1TF and MDS. It's often recommended in high-risk environments, cloud servers, systems handling really sensitive data.
But it doesn't fix everything.
No, it doesn't protect against all speculative execution attacks, just the ones that rely on SMT. And it is a trade-off, right? Security versus potential performance loss. Intel often characterizes the real-world risk of some of these as complex to exploit. For a typical home user, the performance benefit of HT might outweigh the theoretical risk.
But disabling is a solid option if you have a lower risk tolerance.
Definitely. Or if you're running multiple VMs with different trust levels, for example.
Okay, let's bring this all back to that specific chip, the Core i7-12800H. 6 P cores with HT, 8 E cores without. 20 threads total plus thread director.
So if you disable HT on that chip, you go down to 14 threads, 6P plus 8E. Peak multi-threaded performance will drop, but you still have those 8 E cores contributing significantly.
Single thread impact, likely minimal gaming.
Probably less dramatic than on older CPUs without E cores.
Yeah.
You've got 6 physical P cores for the game and 8 E cores handling background noise. You might still see some benefits in frame time consistency or stability in specific titles, but maybe not huge FPS gains. Testing is key.
But you would see lower power draw and heat.
Almost certainly, yeah, which is nice in a laptop. And you'd close those SMT-specific security vulnerabilities on the P cores.
So the E cores and thread director really changed the calculation compared to older Intel chips.
I think so. They handle a lot of the multitasking load that HT used to help with, and Thread Director tries to optimize things automatically. Disabling HT becomes less about general performance and more about targeting specific issues. Stability, maybe niche gaming improvements, thermals, or security hardening.
It feels like the trend might be moving away from relying solely on HT on performance cores, with more physical cores, especially E cores, and smarter scheduling taking up the slack.
It seems that way. We might see HT become more of a niche thing on P cores or maybe evolve further.
So wrapping this up, what's the recommendation for someone listening with an i7-12800H or a similar hybrid chip?
For most users, honestly, probably just leave hyperthreading enabled. The default setup with the hybrid architecture and thread director generally works pretty well out of the box.
But there are reasons to consider disabling it.
Yes, but be specific. Only really consider it if, 1, you're experiencing stability problems, maybe in certain game, that demonstrably go away when you turn HT off. 2, you test carefully and find consistent, meaningful gaming improvement in the specific games you play often.
Not just chasing benchmark numbers.
Right. 3, if maximizing security against those SMT-specific threats is a top priority for your use case. Or 4, if you're in a thermally sensitive situation like a laptop and really want to minimize heat and fan noise.
And you really need to test the performance impact for yourself, don't you?
Absolutely. Don't just rely on general advice. See how it affects your system and workloads.
Okay, great advice. So here's a final thought to leave you with. As processor architectures keep evolving, getting more complex with different types of specialized cores and increasingly intelligent ways to manage them, what happens to traditional hyperthreading? Will it fade away as a standard feature, become a niche optimization? Or will we see new challenges and maybe new opportunities emerge for this way of doing parallel processing? Something to think about for your next system build or upgrade. What will you prioritize?